Hello, I'm Juri, and this is joint work with Leo and Vivi from Heidelberg and Yannick from the Academy of Sciences in Mainz. So some of you might have already wondered, what is the Register Imperii? Well, it's a very large corpus containing lot of information about the Middle Ages in Europe. And contained in this corpus are more than 150,000 small documents, which are called regests, and you can view them as very short summarizations or abstracts of the charters which were issued by the Holy Roman Emperors in the Middle Ages. Starting from, this is Karl Martel around 800 to Maximilian the First around 1500. So the corpus bridges almost 1,000 years of history. It's important to note that the regests themselves, they didn't originate in the Middle Ages. They originated starting from the, I think, 18th century or something, and were created by lots of different peoples. But they describe in a short sentence what happened in a charter which was issued by a Holy Roman Emperor. For example, this is Friedrich III, and he, in January of year 1453, he grants some Count Hugo of Montfort the right to hold in some city a market on every Tuesday. So many regests are in a very similar format, just with different actions. For example, the king might decide to punish some city, or he wants to, he declares that he has received some taxes and lots of stuff like this. And some regests, they also contain historiographical descriptions about events which took place, like battles or a birth or marriages. And what does historic itinerary research do? It's a very important field of history research, and it investigates the traveling routes of medieval entities to, for example, examine their influence and reach. And the Register Imperii should be an ideal corpus to do this. Why? For example, this is Siegmund, and he in 1410, on the 6th of August, he issued a charter from a name called Ofen. On the 2 days later, he issued another charter again from Ofen, and in 1410, he issued a charter from nobody knows where. Maybe the creator was lazy, or it was not possible to disambiguate the place. And on the 9th of August, he issued a place again in Ofen. Here it's not really sure, so the creator has put a question mark behind the place. And on the 5 days later, he issued a charter in Reil, where he gives some count, some protection. And in 1418, so 8 years later, there are lots of regests or charters in between. He issued a charter from Constance. So we know he traveled from a place called Ofen, over a place called Reil, to lots of other places, and finally to Constance on the 28th of January 1418. And so the straightforward thing to do would just project these place names onto maps so we can follow the itinerary of the king. That's easy, right? Or is it? Here, when I enter the place Ofen into OpenStreetMaps, I get lots of different places scattered across Europe. Here in southern Germany, here one. There are lots of places which are associated with the name Ofen, and even here in Hungary. But the correct place name, the correct place in this case, is this one. It's down here. It's Ofen. That's an old name for a subpart of the Hungarian capital Budapest. So it's not even contained in the results of OpenStreetMaps. And what happens when I put this in Google? Google suggests me to places where I can buy ovens. So that's nice because I don't have one, but that's not what I exactly need right at the moment. So let's enter this in GeoNames, and we again get a candidate list with different places scattered across Europe, but also even here Ghana, yeah. So scattered really across all the world. But now we are lucky and we have the correct location in our candidate list. It's contained in alternative names which GeoNames captures. Well, it's really a nice property of GeoNames. So to sum up, it's not so straightforward to simply map the given place names onto maps to follow the emperor's itinerary. So to address this, we engage two main problems. Place name prediction. You have seen that some place names are just left empty or are stated as unknown or with a question mark. So we want to assert that we want to predict the place name for this, for which we have also candidates. And the second step would be to disambiguate the different location candidates for a given place name. And for the place name prediction, we performed a small experiment where we just trained a simple text classifier to predict the place name. We did this by dividing the documents into two parts. One part for where every document, every place name, we know we have a candidate list of locations, and the other part which are left empty or we don't receive any candidates from our geodatabases. And so the first part, for which we know in which place name the charter was issued, we just remove randomly a few place names and try to predict them. And as baselines, we have the most frequent place name for a given issuer or emperor, and the place name of the time-wise closest anterior guest, for which we know we have a candidate list of possible locations. These are the results of the experiments. In the first column, we have the percentage of issuers where the method performed best, and by far the simple last place name baseline outperforms all others. The same happens for the percentage of correct choices in total and the percentage of correct choices averaged over all issuers. So trivially, we decided to replace all place names for which we don't have any candidates or which we don't know of, to replace with the place name from the time-wise closest anterior document. So that's what we have made sure yet, that for every place name we have a non-empty list of candidate points. So of course there's a problem. The correct point might be not even contained in the candidate list, but we didn't tackle this in this work and leave this for future work. And for the coordinate prediction, where we want to disambiguate the paths of the kings and emperors, we model the itinerary of an emperor in a directed acyclic graph. And our assumption is that the path with the lowest traveling cost should approximate the path which was traveled in reality. So how does that look approximately? Here again we have Sigmund. If you recall, he started in Ofen in Hungary and traveled over rail to Ofen again. And for Ofen, let's say we have 16 different possible candidates as points on the map. And for rail, we have 39 different points. And for Ofen again, of course 16, and in total, only for this one emperor, there are 13,628 time steps, and over a period from 1410 to 1424. And our assumption is that if you find the shortest path in this network, this should approximate the path traveled in reality. And of course, what's left to do is to design a cost formula, which has to be where we have to find which then makes possible to find the path with the lowest cumulative cost. And this is our edge cost heuristic here. The first part is the straight line distance, simply from one point to another. This part, it increases the bias towards populated places, because many places of medieval significance are still quite populated places today, for example, Nuremberg or Rome or Venice. This part biases towards exact name matches, because we also want to keep inexact name matches. Like, for example, if a place name was stated with Frankfurt, we want to keep the possible candidates for the city Frankfurt. And this one, this part biases towards the inherent rankings, which are returned to us from the geodatabases. And this shortest path selection that enables us to obtain for every regist an event a tuple of predicted latitude and longitude coordinates. And additionally, on top of that, we compute centroids. So for every place name, we compute its most centered coordinate points. And the intuition is that many and frequent place names have unequivocal points of references, for example, Rome or the city of Nuremberg. And our gold standard, which we use, this is data fresh from the oven. A couple of bachelor student interns, I believe, at the Academy of Sciences in Mainz. They retrieved 10,000 different place names, which can be found in the Register Imperii, and disambiguated them. So this means that qua design, the gold standard cannot possibly account for cases where a place name, where a king or an emperor might have visited one place with the same place name, but different coordinates at two different times, for instance. And our resolutions, what the graph-based shortest path finding algorithm gives us, are event level resolutions. So we allow for the possibility that at one point an emperor might have visited a place with the place name X, but with coordinates epsilon, and at the other time he visited a place name with the same place name X, but with different coordinates Z. But nevertheless, it's the best we have to evaluate against, and should give us some feedback how well our disambiguation steps performed. And you can see on the x-axis, this is time Register Imperii bridge from 700 to 1500. And on the epsilon axis, we have the deviation from our predicted coordinates to the gold coordinates, to the human annotations. So the lower, the better in this case. And we see that this is the optimal path, optimal shortest path, with the centroid post-processing step. It's always more or less the lowest line here, so that's good. And two interesting phenomena we find in this graph is that here there's a huge time span with many errors. But in this time span from 700 to 1000, it's even difficult for humans and sometimes even impossible to discriminate between places or place names. And in this time span from 2000 to 2300, were the Stauferkaisers, and they traveled a lot in Italy, and the place names are, here we have this one, or Roncaglia, never heard of that, maybe any one of you, or Salerni, that's probably refers to Salerno near Naples, and Panormi, I don't know where that is, and so these are also very difficult in their time span. It's reflected by our evaluation results. And now to the one important question: did we find the correct oven? So this is from our optimal path search, the predicted latitude 47.5, and this is from our optimal path search, the predicted longitude 19.0323. And the same output we have from our centroid post-processing step. So we can just look onto a map, and we are happy that these coordinates refer to the right oven, which is a subpart of Budapest. And what would happen if we would have performed the naive coordinate selection step, for instance, by randomly selecting one? Then we would have, for example, this oven here near Bremen. But the correct one is here. So that's quite a big error we would have by a naive coordinate selection in this case. And what we also found by inspecting some the outputs of our method manually was that in some cases the human interns, they made a mistake. For example, here the place name of a register or charter was Sulzbach, and this is the human annotation, and this is false. This Sulzbach didn't even exist in the Middle Ages, and this is the correct location as determined by our method, which is today known by the name Sulzbach-Rosenberg. So there were two cities, Sulzbach and Rosenberg, and they merged in 1900 or 1800. So maybe the human annotator, he was confused by this merger and only took in account Sulzbach with the exact same name. And so our conclusions from our experiments are that the optimal path predictions are better than selecting a path greedily or even randomly, very naive coordinate selections. And this provides evidence that the edge cost heuristic formula we designed was not totally wrong, and indeed provides some useful information to disambiguate the paths. And our method can also capture some human annotation errors. And a side aspect from our experiments was that in some times the place names or places are much more difficult to disambiguate than in others. And for our future work, we might want to improve the place name predictions by maybe experiment with more sophisticated time series prediction models, which take also account clues from the document text, from the actual text content itself maybe. And another performance boost could come from a proper place name normalization step. For example, we have varying writings in the corpus of the city Frankfurt am Main, Frankfurt, Frankenfurter, which is very different, and Frankenfurt. And secondly, we could improve the coordinate prediction by improving the cost heuristics or altering it and taking into account some gazetteers of historic place names and their coordinates. A caveat, though, in this case is the question, do they generalize well over this large time span covered in the corpus, almost 1,000 years? And what would be really cool would be to mine and resolve the rich place names and place name references inside the actual textual contents. And that, I think, will be very difficult, but yields very nice new methods for historians to statistically investigate the medieval times. For example, in this example, Regest, which was issued in Wien, we only took that into account, this place name, the place name from the actual location where the charter was issued. In the text itself, we find also mentions of 1, 2, 3, 4, 5, almost 10 other different places or place names, and it would be really nice to to mine them and resolve them. And that was it from my part. Thank you for your attention.
One suggestion for the factoring of your equation that Sigismundus had a residency in Offen, so there's more chance that this Offen is his residency than some random other Offen. And I guess that all emperors has a list of residences or castles. This makes some sense.
Yeah, that could be very useful information. I don't know, do you know a corpus or database where such is contained? For the...
No, I don't. And I'm pretty surprised that your source doesn't contain the precise resolution of this historical base names. Because usually the critical editions of this chart should have an index of locorum, which should solve this issue.
Yeah, so the regests, they were created later, starting from 1800, and they were created by many different people, and just some people, they looked at the charter, summarized it, and put the name of the charter, where the charter was issued, or which they thought was where the charter was issued, into the regest given place name, which is, for example, which we end up at Ofen here in this case. And in many cases, in the earlier Middle Ages, many place names are not even distinguishable for humans, because many places don't exist anymore, and it is not well known where they were on the map.
Yeah.
Yeah, maybe we could talk later.
Thanks, I like this a lot, so, and a nice talk. At the end, when you were talking about future things you could do, most of the things you mentioned would involve getting other sources of information, and somebody else suggested one. One thing that occurs to me that maybe you could also do with the same information would be sharing information in your inference across multiple itineraries. Since if I understood you right, the cost function is fixed, and so you're not sharing information about different itineraries when you're doing inference. And I wonder if that would be possible to do in your data. So, for instance, if you saw A and then B, and in some other itinerary you saw A and then C and then D, and C was easier to disambiguate, then if you did joint inference across the whole corpus, you would be able to increase the likelihood of a particular identification of A and D.
Yeah, that's a very nice idea. Yeah.
I mean, in a way, right, you say, well, then you have to come up with a model that allows you to do that.
Yeah.
Then, thank you again.